Okay, good morning, everyone. This seems to be working. Okay, so in the next 45 minutes, we will do a quick wrap up on function. We'll also look at the dispatch system and also talk a little bit about documentation. So the point of this class is mostly to go through some of the questions that a few of you had over the last week and some concepts that require some clarification. So let's restart from where we left off last week, which was defining a function called diversity. And this function is going to take a series of values, and it's going to be presence or absence of some species. So we are going to return the sum of x. So that is, in a sense, this little block here is the most basic way to define a function. It has a name here, so the name of the function is diversity. It has one argument, which is x, and it does something to x, which is take its sum, and then it is going to return this thing, the sum of x. So the return keyword is, remember that a function is supposed to be a box, and nothing comes out of the box except what goes after return. So that is an important concept in Julia and in all of programming, which is called the scope. And the scope is a way of saying that variable exists in some context, but not in others. So if we do something like a equal 2 here, we're declaring a variable called a, and we put the value 2 in it. This variable is not existing outside of the function. So when we call the function, the variable a will be created. And when the function is done, this variable will disappear. So the way to make sure, and there are some keywords we can use that make it not disappear, but they're not really something that we should be using anyway in most of the cases. So the way to make sure that we get a result back from our function and that we can be explicit about what the result is to use the return keyword. So let's try, and we have a presence absence list of species. It's going to be true, false, true, true, false, true. So if we call diversity on this list and we execute all of that, let me just start my terminal. So we run the function diversity. It is going to tell us that we have one function called diversity, which has one method. Yes, so diversity is a generic function with one method. We are going to make a vector of Boolean value. So presence absence is an array of Boolean value with 6 elements. That's good. And if we run diversity, on that, it is going to make the sum of this. And because Boolean value correspond to the value 0 or 1, we know that the sum of that is going to be 1, 2, 3, and 4. Okay, that's good. So we have declared a function, like a method for a function called diversity. One thing that we should do, could do in Julia, is that we could specify the type of the arguments of this function. So we are going to be adding a little bit of information here, which is that x must have a type t. So the colon t, it can be whatever. It could be colon s if you want. The convention is to use t for type, mean that x must be of the type t. And then we use this little bit of notation. That's just a convention. There's no, that's not necessarily a particular reason for why it's using where and curly brackets. That's just the way it is. And we say t is going to belong to something. And the thing it's going to belong to here is an abstract array of Boolean values. So why abstract arrays of Boolean values? There is a very long documentation of the various types, and using an abstract array of Boolean values is going to let us capture two different things that I'm going to show you in a minute. So we have a function which is called diversity. It takes as argument something that we call x internally that must be of type t, and t is going to be an array of Boolean values. So if we do this thing now, we can rerun this function. And one thing that is interesting here is that diversity is now a generic function with two methods. And let's question why, because we could use the @methods macro. And that's going to tell us that we have defined, is it functions method? I don't know. Yes. So it's going to tell us that we have one function called diversity, which takes as an input x of type t, where t is an abstract array of Boolean values. And then we have another method, which is diversity of x, which is going to be applied where the type of x is not matched by something more specific. This line here is interesting because we can also restrict the number of dimensions that we want this array to have. For the moment, we're going to assume that it's a vector and not a matrix, but if we want, we could restrict that to being a vector. So that is our first definition of the function. It's diversity for Boolean values. Because we sometimes we have diversity using other other type of information. So we can have, I'm going to put it here. No, I'm going to put it here for a reason that will be apparent later. We can have diversity for things that are quantitative values, numbers. So in that case, we say, well, I'm going to write a function called diversity, but I want, let's say we want that to be a vector, right, of some type t, and we want the elements of this vector to be numbers. So whenever we call diversity on something that is a vector of number, it is going to do something, which for the moment is empty. And by the way, that is something, a function that does nothing is acceptable, right? So if we call diversity of rand 3, it's going to do nothing. Implicitly, because we have not put any arguments or instruction within the body of the function, but we can also write return nothing. And we run the same thing again, and it will return nothing. So nothing is a keyword that we can use in some cases when a function is going to return nothing. I tend to use that quite a bit, and we will go through some examples where it is useful later during the class. So when we want to call diversity on something that is a series of numbers, we have different possibilities, right? We have possibility number 1, we want to be measuring Shannon's entropy, or possibility number 2, we want to be measuring Pielew's evenness index, for example. So, and that's two measures of diversity, and we need to switch we need to be able to switch between one and the other. So let's say that we want to, measure the diversity of Shannon. So to do that, we first need to remove all of the values that are either 0 or negative, because Shannon's diversity is working on frequency. So we are going to get a something called only positives. And to get the values that are only positives, we are going to use a construct called filter. Filter, as you will see for the documentation, takes two arguments. The first is the documentation, the function, and the second is the collection. So we are going to be doing something on n. We are going to be filtering the value of n, and I want to check. Yeah, and so we are going to define here a function that is only within the single line, a one-liner function. It's going to take a value v, and then tell us if v is larger than 0. So if we do that, let's say we do n equals 1, 0, minus 3, 2. And then we do filter is v greater than 0 of the value of n. It is going to give us 1, 2. So that's what we want, right? We want to have only the positive values. The next step is to get the frequency, and the frequency are going to be only the positives divided by the sum, so that it is going to sum to 1. And then, as you remember from your ecology classes, the value of h is minus the sum of p times log of p. And remember that the using the dot here means apply the function to all of the elements. So log dot p means take the log of the value within p. And we can return that. So we can return h. If we run this function, we have a new function called diversity here, and it's going to be measuring Shannon's entropy. So we can run diversity on that. It's going to tell us that the diversity is really high. And if we run diversity on a sample that has only the same value, it is going to tell us that the diversity is lower. Let's think about things that we can improve here. There are a couple of different things that we can do. The first thing is that on line number 10, we are using 0. I say, give me something that is larger than 0. But 0 is an integer number. And maybe we're not using integer numbers inside our function. Maybe we're using floating point. Or 0 is an integer 64 value. Maybe we are using ent8 value, because we know that the value only going to be very small. So let's say we do that, and then instead of 0, we are going to use a function which is called 0. And the function 0 is going to do something that is really interesting. It is going to return the additive identity element, which is a very fancy way of saying it's going to return 0 for a specific type. Just because, remember, there's a difference between 0 as an integer number and 0 as a floating point number. So what we want is v to be larger than 0 of type t, because we know that type t is going to be a number, and we want the 0 of this specific number. So that's not going to be changing the results, obviously. Well, not obviously, but hopefully. And we're going to get these different results. Okay, so that is our diversity function, and it now has a new trick, which is it is returning values. It is comparing the value to the proper 0. That's not going to be making a lot of difference, but it's very clean. What is missing here? So what is missing at the moment is the ability to switch between the two measures, which are Shannon's entropy and Pearl's measures of evenness. And you might also remember that Pearl's measure of evenness is Shannon divided by the natural logarithm of the number of species in the collection. So it's h divided by log of s. How do we switch to that? So we don't really want to make a new function or to have a new method, but maybe we could use one of the concepts that we've seen. And one of the concepts that we've seen is a keyword. We can use a keyword argument And we are going to call it normalize equal false. And normalize is going to be a Boolean value. And so what we're saying here is this function is accepting a new argument, which by default is going to be false, but it can also be true, but it has to be a Boolean value. So we have the value of h here. And so what we can do is if normalize if normalize is true, we are going to return h divided by the log of the number of species, and the number of species is the length of p. Because we have removed the species that are either negative or not present. We're going to return that and be very explicit. And then we are going to return h if normalize is negative, is false. So let's check. If we rerun that, it is going to give us something that is not bounded. So that's Shannon. But if we add normalize equal true, it is only going to give us values that are bounded, so values that are between 0 and 1. What is interesting is that we still only have one function called diversity. Either it's measuring the diversity of presence or absence, or it is measuring the diversity of abundances in a way that is unbounded, or it is measuring the diversity of abundances in a way that is bounded between 0 and 1. But you don't need to remember all of the different values. You just need to remember, well, it's called diversity, and depending on the type of arguments, it's going to do different things. So let's get rid of that for a minute and focus on our functions. One of the issues that we might have is that we have essentially one keyword, diversity, that does multiple things. And we would like to know what these things are. And so one thing that is very important is that we can write a documentation for the function. And the syntax, which again, it's the way that it is. It's 3 double quotes and then 3 other double quotes, is going to be an annotation of the function. And whatever you write within these 3 double quotes is going to be the help for this function. So this is the help. If we run that and we do question mark diversity, we're going to see this little text pop up. This is the help. So of course it's extremely uninformative because that's not something that tells us what the function does or how to use it. One thing that is generally a convention is that the first line of the documentation is going to be one indentation, or like 4 spaces, and then the signature of the function. The way of saying, I am documenting specifically this one method. And if you are familiar with the type system, you know, okay, that is a version that is working on Boolean values. And then we can write a little descriptive paragraph. So returns the number of species in an array containing Boolean values where true represents the presence of the species. So that's a documentation that is slightly longer. And again, if we rerun that and we look at the help of diversity, we have something that is a whole lot nicer. We have the signature of the function that is now in a different color because we use this little indentation, and then we know what it's doing. So here is a function, here is the signature, and here is the here's what it does. We can do the same thing for the other diversity function. So let's go here, one indentation, and so it's going to be calculate either the Shannon or Pielu evenness. I don't know how to spell evenness, and I refuse to learn, of a vector of abundances. So this function does a lot of things. So it's important to be clear about what is going to happen. So if the vector of abundances contains value that are not positive, they will be removed. So this is telling us essentially, well, we have this line here, we're only going to be working on things that are positive. What else is there to say? There will be no warning when this happens. In some situation, you might want to say, well, you had negative values, so I remove them. Here's a warning, just so you know. But here, we have not made a warning. It's going to be silent. And so we just say, if we remove some of the abundances, we won't tell you. We can change that later if we want, but for the moment, that's good enough. This method also accepts a keyword argument, which is called normalize, which is of type bool and defaults to false. And then we're going to be documenting the behavior of the function. So this indicates whether the evenness should be normalized by the log of the species richness, which is Pielow's index, or not, which is Shannon's index. And now we are going to rerun this thing and look at the help of diversity. So what is nice is that we now have two different paragraphs of text. We have one paragraph that is documenting the behavior of the method using Boolean values, presence or absence. And then we have the documentation for the behavior of the function when called on a vector of abundances, which is really interesting, I think, because it gives us a lot more information. So we know, depending on the type of value that we feed to this function, we are going to know what the different keyword arguments are, what is going to happen, and what we should expect. So you can have behavior of the methods that is extremely specialized to what you want to do, and you can also explain that to the user. And the user is not like some abstract person that you make up in your mind. The user is yourself in like a day or a week or 5 years. And so it's important to take some time explaining what the function does. That is the first step of writing documentation. It's very important. I'm going to expect that you do it when you write function for your project and assignments. And it is, again, going to help you a lot. One of the issues with writing documentation is that it's not kept to date, up to date automatically. So if you change something in the behavior of your function, you need to change this thing in the documentation as well. You still need to check that the documentation is up to date with the code. Okay, so that is one level of documentation. There is another level of documentation that is meant for not you as a user, but you as a developer, and that is commenting the code. Commenting the code is immensely important because it's just explaining in plain language what you are doing. Dax, you have a question about an error message you are getting. Could you either tell me what the error message or the question is? Just put that in the chat and I'll try to see if I can reproduce it. So once we have method error, no method matching diversity, array float 64.1, normalize equal true. That is interesting because it should not. Let me try Well, there is, okay, so the error that DAC is getting, I'm going to copy it here, and then I'm going to discuss the possible reason for that. So the error is no method matching diversity of an array float64 with a single dimension or normalize equals true. So that means that you call the function diversity with an array of floating point numbers that you try to normalize, and it is not working. So Zach's initial diagnosis is that may be okay because there's no specific method that says array float64 1, which is true. There is no specific method. And that is the beauty of the type system here, is that we do not need a specific method because there is a method for all numbers. And float64 is somewhere under the hierarchy of numbers. So one thing that's going to happen is that when we are calling diversity on an array of floating point value, it's going to replace abstract by a floating point value and then create the specific version that we need. That's going to happen independently. We don't have to do it. We don't have to define diversity for every type of number. Yeah, and so whenever you add something to the to a function, or when you change the function, just make sure that you run it again so that the new method is here. It doesn't run automatically. So if you change the code of the function and you want to use a new function, you need to run the entire block again, which is Alt and return, I think, in Visual Studio. Okay, so comments. Commenting the code is really, really important. It's going to, it's also very difficult because when you write something, you know what you're doing. You have this mental image of the code in your head and you're like, I will always remember that forever in my entire life. And then you go and grab a cup of coffee and you return to your computer and you've forgotten everything that you've done and you're unable to read your own code. Reading code is really, really difficult. That just, if you still have the error message, send me your code after the module and I'll debug it real quick. So it's important to help you in the process of writing the code. So comments in Julia can be in a single or multiple lines, and they start by the pound sign. So what is important, it's not necessarily to say, let's write a bad comment. We filter n so that only positive values remain. So that is a bad comment because it's telling us the same thing that is in the line immediately under. It's not giving us any idea as to why we are doing it. And so a good comment is documenting the intent of the code, the purpose of the code. So let's use a block. So to define a block of comments, it's pound sign equal and then equal pound sign. And we're going to say like evenness measure only work on positive values. So we need to remove all of, so we need to keep only these values. And then we can say, well, because this method can accept any number, we will compare the values to the appropriate 0. So this is a, I don't know, could you wrap my line, please? No, it's not, okay. I'm going to do that manually, like an animal, I guess. Yeah, so this is describing what is happening, but it's also explaining us why. So in a sense, we know that if we're changing this line, there is a chance that we will be changing the very important specific behavior that we introduce in this line, which is only keep the values that we want to keep. What next? So evenness measures work on relative abundances, which we can get by dividing every element by the sum of the abundances. Let's also make that a long comment. And then we close it. Okay, and so we have documented the next line. Let's just give the code some breathing room. Here, we don't need the terminal at this point. I'm going to close it. Yeah, probably. Okay. Let's add another comment here, and we say, well, the both Pielu and Shannon require to get the sum of the product of abundances and their log. And then this gives a negative value, so we return minus that. I can type. Okay. Let's add another comment. It seems long and boring and painstaking, and it is, and I'm doing that on purpose. I want that to be excruciatingly uninteresting, just to prove a point that I will get at very shortly. Finally, if we want to get Pielu's index, we need to divide Shannon's by the species richness. And then note that we need to use the correct species richness, i.e. the number of positive abundances. Okay, so what was my point? My point was that we had a function, we had a method called diversity that was 5 lines. And then we turned it into something that goes from line 26 to line 58. So it is now 32 lines long. And most of these lines, they do nothing. If we look at a measure that is called the number of significant lines of code, or SLOC for short, we have 1 here, 2, 3, and then if we want it to be crafty, this would be a 4th, right? So we have possibly 4 lines of code that do something. The rest of the lines, they don't do anything for the computer. They do things for us. And what they do is that they explain in detail the behavior of each of the elements of the function. So one thing that is very obvious very fast is that when you are working on a program, most of the things that you are typing are not going to be code, right? They are going to be comments, and they are going to be documentation. Because if we look at the entire function, it goes from line 15 to line almost 60, right? So that's 45 lines of code to define this method, only 4 of which are actual code, and then we have 2 for the signature, right? So it's like about 10%, and that's a good order of magnitude of how much code versus non-code is going to be in any given program. And so writing code is one thing, but most of your time is going to go into making sure it works, that's the first thing, but also documenting and commenting. And the difference between a code that is well documented and well commented and a code that is not documented or commented is that the first one is going to be easy to use and easy to adapt because you know what is happening and you know what to expect. And you can also understand why some of these decisions have been taken. So why are we using 0 of t instead of just a number 0? Well, whoever wrote this code said that's because we can accept any number. So we want to compare to the correct 0. That's us being fancy for no reason here, but the point is if you take a decision that is important, you can document this decision within the code. It's not something that needs to go into documentation, by the way. Your user does not care that internally you are comparing to the correct type most of the time. But if someone wants to go into the inside of your function, into the internals, and then change it, and then adapt it, or maybe try to figure out where a bug is coming from, well, that is going to be important to tell this person what you have been doing or why. So just to summarize, we have seen how to write a function, how to use dispatch properly. We have, we can write some documentation and have the documentation show up in the terminal, and then we can write comments. That is sort of good practices, right? We write function, we make sure that the type of the arguments are properly specified, so we don't run a function on wrong arguments. We write the documentation for the function that gives a signature and that also explain what this function is going to do and give information about how to use it. And then within this function, we write comments that explain what the code is doing for people that want to see what the code is actually doing. And that is a good practices. And most of the time we don't use them. When we do programming for science, we just want to get science done quick, often dirty, and we're not adhering to these good practices. But there are two situations in which they're especially important. Situation number one is when you're learning. When you're learning programming, it's very important to follow these practices because you are going to be documenting what you do, and you're going to be keeping notes on your process. The other situation in which it is very important is when other people are going to be using your code. Because if you write code that is improperly documented, or the documentation is wrong, or the comments are misleading, and I use it and I get the wrong result because of you, I'm going to get really mad. And you don't want people to be mad at you, especially not for not following good practices. So I had a conversation with one of you this week that said, well, I took the code that you wrote and I did a lot of comments and it made the code worse. No, it made the code better. The point is when you see a piece of code that is not commented and you want to use it, understand what's going on, perform your little code dissection, and add comments to explain what is happening. That is literally one of the most important things you can do. And whenever you have a question, put a comment about I'm not sure what's going on here. And then try to figure it out. And then when you figure it out, just replace the comment by, okay, I got it. This piece of code is doing the thing. That is going to bring you from a novice programmer to someone who can actually work on things. So that was a wrap up on how to define functions. We have 5 more minutes-ish before the first module is over and we break for 15 minutes. And I would like to talk about iteration a little bit more. So let me just change the language mode to Julia. Okay. So, for loop and what's up with them? For loops are the single most confusing concept in programming, I think, just because they do something that is not what we expect. And what they do is that they are silently changing the content of a variable. So let's go in, let's do that. For I in 1, 2, 3. Let's do 2i end. So that's a loop, right? It's not returning everything. So let's add a println here so that it prints 2i. and then the result is 2, 4, 6. If we were to write that as a text, right, just to understand very explicitly what is going on, I would say it would go something like this. Create a variable called I. Put the first value of 1, 2, 3 in I, and then I is now 1. Go into the body of the loop. So it's print the result of 2 times the value in I. And then we reach end. We have reached the end of the loop. Now go back. And then put the second value of 1, 2, 3 in I. I is now 2. We do that over and over again, right? Up until the point where there are no more values in 1, 2, 3, which we have not put in I yet. Loop done. So this is tracking the content of the values in a for loop. It just takes some practice. There's no, you can read the documentation, you can look at for loops, but what you should be doing if you don't get them is experiment. And then say, okay, I'm writing this thing, I am expecting this behavior. What do I actually see? What is the behavior that I actually get? And then if they're different, try to understand what your expectations were, and try to understand why it doesn't work. But the reason for which a for loop is such a complex concept, it's because if you try to unroll it in plain language, you get this thing. And so if we had a second for loop nested inside the first, then we would have like this entire block of things nested every time. And so it is legitimately something that is going to break your brain a couple times, and it's normal. That's probably the programming concept I spend the most time explaining, and I've talked with many colleagues who have the same issue with their students, and it's not an issue with you students, it's just for loops are complicated. There will be a point where you get it and you will look back and say, oh, could I not get it before? And the answer is like everything seems easy once you've mastered it, but for loops takes a while to really get. It's a good thing that you will get an opportunity to practice them, because the first assignment is mostly about using for loops. Okay, so that was, I don't really need to save. I'm going to save this one and send it to you. And that wraps up the first module. So we're going to break for 45, no, we're definitely not going to break for 45 minutes. We're going to break for 15 minutes. Get back here at around exactly 10:15, and we will talk about some advanced things we could do with memory and how to deal with multiple arrays of numbers. This question, why does I in 1 to 3 doesn't work? It should, and we'll get to that after the break. That's a good question. Yeah, it should be working. I'll get to that after the break. If it doesn't work, send me a screenshot of your code in Teams and I will have a look. All right, I'll see you in 15 minutes.